So today is an extension of lesson 6. This is slope-intercept form part 2. What do you do if the intervals are not 1? So every graph that we've looked at so far, it's been each square to the right was worth 1, each square up was worth 1. And so now what we've got are graphs where the x-axis, in this case, is counting 2, 4, 6, 8 per square, and the y-axis counting 2, 4, 6, 8. But notice they're not worth 1. So we've got a few things that we need to consider. Option 1, we still want to start by identifying those friendly points, right? The points that are right on the crosshairs. But now we need to look here and say this is actually up 4 because it's 2, 4. And then this is to the right, 2, 4, 6. So our slope is going to be, again, rise over run. So no big deal. Rise over run, 4 over 6. I have to put it in lowest terms, in this case, 2/3. So if we are finding the slope and the lines, each one of those little squares is not worth 1, we have to make sure what they're actually worth, that's what we're counting by. Instead of saying up 2, this would be up 4. Instead of saying right 3, this is right 6. The second one that's here, you'll notice that it's 2, 4, 6, 8, 2, 4, 6, 8. Not a big deal since they are the same, but we still have to find our two friendly points. When we do our slope and we say rise, this is down 2, 4, 6, negative 6, right 2. So our slope, which is rise over run, would be negative 6 over 2, and in lowest terms, negative 3. Again, not terribly difficult. It does start to get more difficult, however, when you notice that here we're counting like half 1, half 2. The other axis is going 1, 2, 3, 4. We might want to consider another option, and I really like this option. It is a formula that is going to help us find the slope if we know the coordinates that are on the line. So the formula for slope is y2 minus y1 over x2 minus x1. And this is another alternative. So first, if you find those two friendly coordinates like here and here, you want to identify what they are. So this coordinate is left 1, down 1, 2, 3. So negative 1, negative 3. This is right 1, 2. Notice we have to actually check the axis, that this is 2, and then down 1. So we do have to be able to identify the coordinates, but then you look at the coordinates, say this is the x coordinate for the first point, and this is the y coordinate for the first point. This is the x coordinate for the second point, and this is the y coordinate for the second point. So I can do y2 minus y1 over x2 minus x1. And what you're doing is you're finding the difference in the y coordinates, which is your up and down, and then you're finding the difference in your x coordinates, which is your left and right. In this case, it would be negative 1 plus 3 over 2 plus 1. My slope would be 2/3. And I know I'm going into the next picture. But you would say that your slope is 2/3. And you don't have to do rise over run because you're actually subtracting the y coordinates, which gives you the rise, and you're subtracting the x coordinates, which gives you the run. So let's try that one again. That is, again, another option. So if I find two friendly coordinates, so this one is negative 1, 4, and this one is negative half, 3. Well, I don't know. Maybe I want to count the squares and say I went down this much and right this much. Let's try that alternative. If the slope is y2 minus y1 over x2 minus x1, I'm going to say this is the x coordinate of the first point and the y coordinate of the first point. This is the x coordinate of the second point, and this is the y coordinate of the second point. Now, after you've been doing it a while, you probably won't need to write that in. So the y2 minus the y1 over the x2 minus the x1. Because it's subtraction and I'm dealing with positives and negatives, I'm going to rewrite it. 3 plus a negative 4 and negative half plus a positive 1. So I'm going to get that the slope is negative 1 over positive half. Now, that is not going to fly because you cannot mix and match decimals with fractions. So 1 divided by a half, how many halves are in one whole? My slope is going to be -2. You could also do 1 divided by 0.5 if you needed to, or you could check it on a calculator. Last but not least, I have one graph left here. I'm going to pick this coordinate and this coordinate. They look friendly to me. So this one is 0, but notice where I am. Here is 0 and here is -10, so this must be -5. This coordinate is -4. I'm just checking that I'm above -4, and I'm across from 20. So let's try both, okay? You could go down 5, 10, 15, 20, 25, and then you'd go over 2 squares, which is worth 4. So you could say the slope is -25 over 4. You can leave it as that. That is a perfectly acceptable answer. The other option is to try that equation, y2 minus y1 over x2 minus x1. I might not have to write it at this point if I've kind of gotten used to it, but maybe I'm going to say this is my x1 and this is my y1, this is my x2 and this is my y2. So -5 minus 20 over 0 minus -4. I would rewrite it to make sure I don't make a mistake, and I would still get -25 over 4 as my slope. They agree. They should agree. I'm doing the same thing, so I should get the same answer for both. But there are 2 options for finding your slope in case you realize that the intervals are not 1.